Hi, you all. Good afternoon. Welcome to my channel. Today, we're going to learn how to name alkenes. So to save time and to prevent lengthy video, I've already expanded all this stuff. So just go ahead and if you still don't know how to expand stick formulas, you can watch my video on expansion of stick formulas to understand what you're seeing here. But it's actually something hard. It's just a method of writing formulas to prevent or to economize space. Now, how do we name this? This is an alkene. An alkene, they have general molecular formula CnH2n. Yeah. So alkenes, they are known for their double bond. They bear double bonds in their compound. So they are unsaturated hydrocarbons. Okay. Now, how do we name this? We know that if you have one carbon, you have meth. You have two carbons, you have meth. Three carbons, both. Four carbons, both. Five carbons, X. Six carbons, X. Seven carbons, X. 8 carbons is helped. Have 8 carbons off, 9 carbons not, 10 carbons you have deck. But alkenes, we don't have meth. So for alkenes, we rule out meth for alkenes. So here, the first thing we do is to count the number of carbons we have. We have to find the longest carbon chain, like I always say. So if you count here, 1, 2, 3, 4, 5, 6, 7, 8. Notice that we have 8 carbons. Let's go again. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons. So when you have 8 carbons, what would you call it? Oct. So we know we have oct. When I'm ready. Okay, so now if you were alkenes, you would have said octane, right? But now we are dealing with alkenes, so we'll call this, the name of this compound is going to be octene. Don't go anywhere, don't go yet, because this is wrong, babe. This is wrong. What we should do is, since we have a double bond, we should identify the position of the double bond in the chain. Okay? The position of the double bond must be put into consideration. So, we're going to count the carbons, we're going to label. Okay? If we were alkane, we would have just written octane. So we have an alkene. So the position of the double bond should be identified. Okay, so you can count from here 1, you can count from here 2, but counting from here will be lengthy because it will give, if you count from here, this double bond, the carbon that is bearing the double bond is going to have a larger number. It's going to be on the carbon with a larger number, which is wrong. If you've been following my videos, I remember when I told you guys that when you want to count, you count from the side that will give the substituent or the functional group the smallest possible number. Okay, so therefore we'll start here. 1, 2, 3, 4, 5, 6, 7, 8. From here we notice that the double bond is on the 3rd carbon. Therefore, this is going to be oct 2, 3, because The double bond is on the third carbon. We are counting from here. Okay, so this is oct2n, or you can call it 3-octene. Any of the above is correct. Oct3n or 3-octene. Wow, it's just simple. It's not that hard. Okay, so we're done with that. Just move over to the second one. Second one, we have this. I've expanded it. This is the same as this, so don't get confused. So I've expanded it already, so we will name, right? Now if you look at this, you will notice that we have double bonds in two places, here and here. Okay, we also have substituents, bromine. So first thing is to count the longest carbon, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And when we have 9, we have none, right? We have none. So we have nonene, right? Nonene. Now, but here, remember I said the position of double bond should be put into consideration, right? So we also have bromine, right? So we have to name, we have to start numbering. Now it wouldn't be right if we number from here, because if we number from here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if we number from here, we have the double bond on the second carbon, and on the last we have 2 and 8 carbon, right? And we have these functional groups, this halogen. So we can name, we can number, right? So the best way to number is from here: 1, 2, 3, 4, 5, 6, 7, 8, 9. With this, we notice that the substituents will have the lowest number possible. So if we're nonene, right? I always tell my people to write out all the functional groups and all the substituent there separately before we combine. Okay, so we have nonene, we have 3-bromo, right? We also have 5-bromo. There's a double bond, and the double bond is on the first carbon. So we have 1 in. We also have the double bond on the 7th carbon, right? So we have 7 in. Any other thing there? No other thing. So we just combine the names. So with this, we will have 3,5-dibromo, right? Non-1,7-diene. Just very simple like that. So we can just write this here: 3,5-dibromo non-1,7-diene. Very simple like that. Wow. Okay, just done with that. Very easy. Notice if you count from here, you have 1, 2, 3, 4, 5, 6, right? If you count from here, you have 1, 2, 3, 4, 5. You have 5,7-dibromo non-2,7, which is wrong because the substituent here have high numbers, which is wrong. Okay. Now Now you're gonna do number 3. You do it yourself. Tell me your answer. I'll be waiting in the comment section to see it. So I'll do number 4. Now this is a cyclic compound. It's a cyclic compound, okay? So, but is an alkene. Is a cyclic alkene. Still the same thing. Don't panic. Can number 1, 2, 3, 4, 5, 6. The same way, like if you've watched my video on Iupac nomenclature of cyclic compounds, you will understand better. Okay, so this one now is this. Then can name it. So we have 4-chloro, 4-chloro, cyclohexane. Woo, very easy, very easy. Okay, you do number 4, you do number 5 too. I've done 1, 2, and 4. You do number 3 and 5, and tell me your answer in the comment section, because I'll be there waiting to hear waiting to see your comments. Thank you very much for staying with me. This is Hughes. Thank you so much, and do have a nice time. Hola. Bye.